Hi everyone. Let's start one small geography session on our VLPIS program. So last class we were discussing about the universe, the basic structure of the geography and the important factors and the tree diagram of it. Now we are going little deep about the each and every particle, each and every portion of the total universe. So, what's the plan for the next Indian geography topic is? This is the basic structure. The initial classes we are going to cover based on the geography, nature, and the scope we already discussed. And the left side tree, you can see universe, galaxy, all those points. So we are going to complete this section first. Then we move to the world geography, and then finally to the Indian geography. And most of the questions for your prelim exams are there from the Indian geography, and for your main exams you have to focus little on world geography. So that is the basic structure of the geography session. So today we are discussing little deep about the universe. We all know what the basics of universe we studied in the school classes and all. And we discuss some basic facts, and then we talk about galaxies, star, planet, moon, asteroids, earth. And we if we focus on earth, there's the origin of it, static, size, motion, longitude and latitude, eclipse, evolution, movements, and that movements cause volcanoes, earthquakes, all those things, and belt causes waves, etc. And the minerals available, the rock types available, and the landforms like mountain plateaus, plains, and fluvials. So let us start with this session. First session we are discussing about the universe. So universe is, you know what, it is something like unlimited thing, and it is a galactic mega structure. So it's very huge and big. So approximately we are calculated like the age of the total universe is 13.79 billion years, and it comprises of number of galaxies. And how we calculated this one, it is using the optical and radio telescopes that indicates the existence of the extents of about 100 billion galaxies. So that means about 100 billion galaxies are available in this universe. We just calculate roughly using the optical and radio telescope. And the most accepted theory that is connected with the birth of this universe is Big Bang theory. So that's the basic fact of universe. Now we are talking about the galaxies. So galaxies are the collection of billions of stars. So they held together by the gravitational pull of their own. And we can give one example as the Milky Way. The Milky Way, as the background picture you can see, it looks like a river. Okay, so Earth lies in this Milky Way, and it is spiral in shape. It's also called as, one other name is Akash Ganga. And there are lots of other galaxies available in this total universe, and the galaxies that is available to our galaxy Milky Way is Andromeda. So after covering the universe and the galaxies, we can now talk about the stars. So stars are luminous heavenly bodies. It is simply hot burning gas. And up to how it reflects, how depending on the color, we can calculate the temperature of the star. If the color is red in color, then we can say that it is a low temperature star, and it is yellow high temperature, and it is blue very high temperature. So that is the highlight. If it is blue, it is very high temperature. So let's discuss about the formation of the star and all. Birth to death, we are discussing from birth to death. So we can simply say that there was initially a cloud dust and a gas, and which resulted starts as a cloud of dust and gas, which what we called as a nebula. And what happened was, this nebula or the cloud and dust contracts and make a dense region in the middle of it. So this contract and make a dense region, we call it as protostar. Okay, so what happened with the protostar? The protostar again condenses to a critical stage of mass. Okay, again condenses to a critical stage of mass where nuclear fusion begins. So there comes the nuclear fusion. And you know that hydrogen of the star are used up, and then the helium begins fusing into the carbon. So that is the highlight here. This is nebula. You can see the figure. Okay, and its contrast to become a protostar, and then comes the nuclear fusion. Nuclear fusion. So that means two heliums mix, hydrogen mixes to helium, like that large energy is creating. Okay, and after this star begins and there is radiation there, and one point of time the helium fusion stops. Helium fusion stops means what? Energy stops. And the star again, the core of the star core again try to contracts and it become more dense and denser. It's the more denser, that means it's create birth to the white dwarf star. So that is what we call as white dwarf star. So the beginning of the, if we start from the cloud of dust and gas, now it is white dwarf star. Okay, so you can see the helium stops and the contracts happens and it creates white dwarf star. So it's not going to end right now. Again, there's a process continues, and this white dwarf star started cooling. Okay, this white dwarf star started cooling, and one point of time, the dark ball of the matter on the coolings, it becomes little more blacky, and now it's gave birth to the black dwarf star. So from where the black dwarf star begins, it's from white dwarf. So that's the point. Started from the clouds, okay, then protostar, then fusion stops, then white dwarf, then black dwarf star. So this is the highlight of it. And you can see this picture, a red giant. I will explain what red giant in the next point. And for small stars, the red giant will collapse under its own gravity and form a very dense white dwarf. So collapse means what? Contrasting. Okay, and it's create white dwarf stars and then it moves to the black dwarfs. You can see the picture. And the Chandrasekhar was one of the scientists, Indian scientists, who discovered the point that it is the limit, it is a point where the star is becoming a white dwarf. So he calculated like this: the mass of the white dwarf, if less than 1.44 times the mass of the sun, then it become a white dwarf. So it's very important. Chandrasekhar limit 1.44 less than that of the mass of the sun. And the red giant star, red giant or the red star, it consumes hydrogen and heliums. Okay, and red star now gave birth to the red supergiant. This super red giant will explode one point and it creates supernova. Okay, and white dwarf, that it's a dead star. So after consuming the hydrogen and helium, the giant star is now become a red supergiant. So what happened to the red supergiant? This red supergiant will explode one point and create supernova, or the changes is there in the neutrons, and or it becomes a black hole. So you can see this figure, simple figure, and we discuss with the cloud there first. Okay, and the cloud, interstellar clouds is there. It give birth to the protostar. As you can see in this figure. So it is interstellar here. Okay, it gave birth to the protostar. And what happened to the protostar? If it is small protostar, then it becomes a red giant. Okay, and the red giant becomes white dwarf, and white dwarf becomes black dwarf. Like that it will move on. Okay, and if the protostar is big in size, that means large in size, then they flow like this. Okay, large in size, it create birth to the red supergiant, and this red supergiant explode one point of time. As we discussed right now, it create 2 points, either neutron star or black holes. Okay, so go through these pictures very clearly. It is very important picture. So next, so we know that Earth is at point, the sun is one of the stars which is close to us, the only star which is close to us. And there are other stars that is also a little close to our Earth, that is Alpha Centauri and Proxima Centauri. Okay, just be aware of this point, Alpha Centauri and Proxima Centauri. Now we will talk about the constellations. Constellations means a group of stars. Okay, so we can make imaginary shapes out of the group of stars, as you can see in this figure. And most of the time it helps in the navigation for the sailors. Example, Orion, Big Dipper, Cassiopeia, etc. And Orion, it's also called as Mriga. And late evening during winter you can see it on the sky. And Cassiopeia is available on the northern sky in the winter season. And there are lots of other constellations too, like this. So Aries, Taurus, Gemini. So we can find imaginary lines using this picture. So it's very important for us. Just go through this constellation pictures. Now we'll talk about our own star, Sun. Okay, hydrogen inside the sun is 70% and 26.5% is helium and other gases, which is equivalent to sun. It is 109 times bigger than Earth, and it is about 150 million kilometers away from us. So, which sun gives away some radiations in the form of visible light, infrared, ultraviolet, gamma rays, radio waves, and plasma waves. So this is a result of the sun's explosion and all. And there is one important point here to know about the galactic center. Galactic center is a center where the sun revolves around it. So it is a point in the Milky Way where sun is revolving around, and the planets around the sun is revolving around the planet, around the sun. So sun is revolved by the planets and the galactic center is revolved by the sun. That is the point. So one revolution of the sun is 250 million years. We call it as the galactic year or the cosmic year. So you can see the original picture by the ISRO points. So you can see the sun is there and the galactic center is there, and the sun is rotating around the galactic center. Okay, I think you are very clear about this point, galactic center. Now we'll talk about the flares, that is means light or flashes of light comes out of the sun. So it's called as solar flares. Solar flares means flash of brightness, and this flash is a collection of magnetic energy including electron, proton and nuclei. That means we can say that these solar flares are charged particles, a stream of charge, a wind of charged particles. And you can see in this figure there is sunspot. Sunspot are the dark spot that is little around this solar flares. Okay, solar flares is come out of the sun surface where you can find dark spot called as sunspot. So this is the basic layers of sun depend upon the brightness level we calculated, and the most inner portion is called as core. That means 15.0000000 degrees Celsius temperature, and just above you can see the green layer. It is called as convection zone, and the dark blue, that means magenta type color, not magenta, what is it, violet color. Okay, violet color, it is called as photosphere. And after that the blue color, you can see it is chromosphere, that is 4320 degrees Celsius, and the final corona, it is the 20 lakhs something degrees Celsius. So this is the layer of the sun where the gas is evolving, and depending upon the brightness level we calculated the total structure of sun. And the core portion, you can see the hydrogen is there. Hydrogen compresses and fuse to create helium, and then helium started fusing, and fusion reaction, the nuclear fusion starts, and energy emits from its surface. And you know what, the sun's atmosphere we will calculate like that. The chronosphere plus the chromosphere is called the atmosphere of the sun. So the atmosphere of the sun, as we can say the atmosphere of earth, the two layer chronosphere and chromosphere will be the atmosphere of the sun. That's the sun atmosphere. And you can see the solar flares are those streams of charged particles, okay, that will flow in all directions. Definitely earth is on the way of this stream, and these streams of charged particles will flow towards the earth, and these charged particles are trapped by the earth magnetic field. And you can definitely see that north pole to south pole there is a magnetic field for us, for earth. So these particles are trapped by the magnetic field, and these particles, charged particles that comes from the earth, will be directed towards the north pole and the south pole of the earth, just because of the earth magnetic field. And as a result, there is a light display or the light show will happens in the northern hemisphere and also in the southern hemisphere. We call it as auroral show or auroral display. Okay, as you can see in this figure, the blast from the sun, spectacular flare expected to reach earth on Thursday. So this recently happened. Okay, and sun's flares suddenly release of the magnetic energy that has built up in the solar atmosphere. So solar atmosphere means what? Solar atmosphere is equal to corona and chromosphere, and these kind of flares can cause a collision of the magnetic field between the sun and the earth. So you can see it's 150 million kilometer away, and the flare expected Thursday Friday time period, and it will come. Definitely these flares consist of the charged particles. It will affect the magnetic sphere of earth, and also the satellite radio grid, etc. And you can see the earth magnetic field, the lines there like this. So lines is there. Okay, I'll show you one more picture which is more clear for us. So see this, the sun flares and the eruption will come and the particles are drawn to the poles colliding with the atmosphere, causing polar lights. So that's the point. Some lights will come from the flares and reach the northern poles, and some will come and reach the southern pole. As you can see there is a magnetic field around the earth. You see that? So this magnetic field creates the, or drive away the charged particles of this sun flare. Okay, and super god gas contained charged particle will reach here, and these flares will definitely affect or effect creating problems on the satellite microchips and power grid and radio interferences. So this is a very serious problem for us too. And as you can see, the charged particle will come to the northern hemisphere where it is called as aurora aurora borealis, and in southern hemisphere it is called as aurora australis. Okay, so that is very important point. As we already discussed about the sunspot, it is a dark appearing area in the photosphere from where the solar flares originate. So this sunspot are little cooler region and appears and disappear after every 11 years. That means there is a cyclic movement. So that's why this point is called as sunspot cycle. And the plage is one term we commonly use. Plage is a brighter region in the chromosphere near to the sunspot. Okay, so you can see the sunspot and solar flare here. So this is the topics we discussed right now. Okay, and the next section we are going to discuss about the planets, cosmets, asteroids, earth, etc. So go through these videos again and clearly make notes and by heart these points. If you have any doubt, let me know. Thank you so much.